Good morning to everyone. I am Dr. Hima Bindu from the Department of Mechanical Engineering, and I'm here to deal with robotics subject. And my today's topic is feedback components, in which we will be studying about the force and moment sensor. Right. My today's topic is about force and moment sensor, which is one of the type of the feedback component. Firstly, what do we mean by how do we measure the force and momentum in the robot? Where exactly is this particular sensor being placed in the robot, and what are the various applications, and how this particular sensor detector will be working in a robot will be discussed in today's class. Firstly, what is the purpose of this particular type of the robot? That is, generally, this sensor is used to determine the amount of force being applied on the robot's end effector and the moment acting at the robotics joint. Right? The main purpose of the force and moment sensor is to determine the force at the end effector, how much amount of the force will be applied on the end effector, and it is used to determine the moment acting at the robotic joint. Right? So, as we can see, this is the figure of the force and moment sensor, where this will be placed at the robot. Here you can see the circular disc, right? This particular circular disc is called as a rim, right? This particular circular disc is being called as a rim, and within the rim we have a cuboidal shape hub being placed. Right, within this particular circular rim, we have a cuboidal shaped hub being placed, where this particular rim and the hub is being connected with the help of the deflection bar. Right, this particular rim and the hub is being connected with the help of the deflection bar. So totally we have 4 deflection bars. Right? So totally we have 4 deflection bars which are helping the hub to get connected with the circular rim. Now this particular circular rim is initially being fixed to the robot's end effector. Right? This particular circular rim is being fixed to the robot's end effector, and this rim is being fixed to the robot. Right? This particular robot's circular rim is being fixed to your robot's wrist. Right? The circular rim is being fixed to the robot's wrist, and the hub of the robot is being fixed to the end effector of the robot, where the movement of the robot's end effector, when the movement of the robot end effector is being done, it will determine how much amount of the force is being applied on the robot's wrist, and what is the movement, how much is the amount of the movement of inertia being taking place for the end effector, robot's end effector. So with the help of this particular force and moment sensor, we will be determining these particular scenarios. So we have totally 4 deflection bars, and for this particular 4 deflection bars, we have 2 strain gauges being fixed. Right? To this particular deflection bar, we can see strain gauge here. Right? To this particular deflection bar, we have 2 strain gauges being fixed. That is, totally we have 8 strain gauges being fixed to the sensor. Right? So totally we have 8 strain gauges being fixed to the sensor. And as the robot starts giving its deflection, right, as the robot's manipulator, series manipulator starts moving. For example, this is the robot's manipulator, and here at the wrist we have the rim being attached, and here to the end effector, this is the end effector of the robot. To this particular end effector we have a hub being fixed. Right, now as the movement of the robot is being initiated, there will be some amount of force being applied on this particular robot's wrist. Right, so this deflection bar, whatever we can see here, will be varying. Initially it is in this particular direction. Right, initially it is in this particular direction, and as there is some movement being taking place within the series manipulator, the deflection bar is getting deflected from its original position. Right, the deflection bar is getting deflected from its original position, and it gives us the deflection of delta. Right, and it gives us the deflection of delta. So with this particular deflection, we will be calculating, that is delta is equal to PLQ by 3EI, where E is nothing but the amount of force being applied on the wrist of the end effector, and L is nothing but the length of the deflection bar. E is nothing but the Young's modulus, that is depending upon the material type we will be taking the Young's modulus, and I is nothing but the moment of inertia. Right, so with this particular formula we will be calculating the deflection, with the help of which we can determine the amount of force being applied, as this deflection is already being known. Right, the difference between the original position to the deflection bar, deflection will be known. Right, delta will be known, the length of the deflection bar is known, the moment of inertia is being known, and the Young's modulus will be known. So we need to determine the load. So this will be determined with the help of this formula. Right, so this is how we calculate the force, how much amount of the force is being applied on the robot's end effector or wrist. Right, as this particular deflection bar is deviating from its original position to some of its other position, it gives you a value of delta, and with the help of delta we will be calculating the force, that is PLQ by 3EI formula. Right, and in the same way we will be determining the moment of inertia also for the same robot's series manipulator. Right, so here are few of the this Fx is the amount of the force being applied in the x direction, Fy is the amount of force applied on the y direction, and Fz is the amount of the force applied on the z direction. Right, so and whereas the amount of the moment in x direction is nothing but mx, and the moment applied on the y direction is my, and the moment applied for the z direction is mz. Right, and these are the strain gauges which are being attached to the deflection bar. So now to this particular strain gauge we will be attaching a potentiometer. Right, to this particular strain gauges we will be attaching the potentiometer circuit. What is the use for attaching the potentiometer circuit? Right, what happens in potentiometer? What do we determine in potentiometer? We have already discussed in the previous session. Right, with the help of the potentiometer we can calculate the output voltage. Right, with the help of the potentiometer we can calculate the output voltage, that is the amount of the input voltage is equal to the amount of the output voltage which is being generated with the help of the potentiometer. So with the help of this particular voltage we can know what is the variation being taken, how much is the amount of current being passed through this particular strain gauge, and how this particular deflection is being taking place, right? How this particular deflection will be taking place, we will be determining with the help of the potentiometer. Now, we will, with the help of this formula, that is force is equal to Cm into W, that is the Cartesian coordinates into the raw values. Raw values is determined by W. So here we are taking Fx, Fy, Fz, that is force in x, y and z direction, and moment in x, y and z direction, that is mx, my and mz. So that particular force and momentum will be determined with the help of the Cartesians, that is C11, C12, C13 up to C18, C21, C22, C28, and here also further we will be getting this up to C81 to C80. That is, this is a 6 by 1 matrix, this will be a 8 by 8 matrix, and this will be a 8 by 1 matrix. So with the help of this matrix, we will be determining the forces, and we will be calculating how much amount of the force is applied in x direction, how much amount of the force is applied in y direction, and how much amount of the force is applied in z direction. In the same way, how much amount of moment is applied in the x direction, and how much amount of the moment is being applied in the y direction and z direction, we will be calculating. So how will we determine these particular forces? So we can see here Fx. When we are considering this Fx, we will be considering Fx with respect to the other coordinates. So Fx is equal to W8, in which direction Fx is W3 plus W7, right? Fx is equal to W3. Here this is Fx, right? Fx is equal to W3 plus W7, right? In the same way, Fy is equal to, what is Fy here? W1 plus W5, right? That is W1 plus W5. Where is W5? Here, right? This will be W5 and this is W6, right? In the downwards direction, right? So Fy is equal to W1 plus W5, right? W1 in this direction and W5 in the other direction. Whereas Fz, right? Fz is equal to W4 plus W2 plus W6 plus W8. We will be getting total in W2, W6 plus W4 plus W8. So this is how we write the equations for force in all the three axes, X, Y and Z axis. In the same way, for Mx, My and Mz, we will be considering it in the same way. That is W4 plus C44, right? W1. For Mx, we will be taking W4 plus W8, right? W4, this plus W8, this one, right? For Mx plus into Cartesian C44 and C48. For the moment in the y direction, we will be writing as W2 into C52 plus W6 into C56. And for Mz, it is W1 into C61 plus W3 into C63 plus W5 plus W7 with respect to the Cartesian coordinates. So whatever are the values here, for example 1, 2, 0, 3, whatever are the values here, accordingly we will be calculating and we will be getting the moment and force with the help of the sensor which is being placed at the robot's wrist and the end effector. So this is how you calculate the force and moment with the help of this sensor. right? So with the help of the strain gauges, as I've told you, we are just going to measure how much is the deflection of the particular deflection bar, right? This particular deflection in the deflection bar will be determined with the help of the potentiometer, which will be attached to the strain gauge, which is being placed on the deflection bar. Right? Understood? So, once again, I'll repeat. The force and momentum sensor is used to determine how much is the amount of force being applied on the robot's fist, and what is the moment which is being taking place at the robot's end effector, that will be determined with the help of this sensor. So, the circular rim, whatever is we can see in the figure, will be placed to the wrist of the robot, and the hub will be fixed to the end effector of the robot, and the robot's rim, sensor's rim and the hub is being connected with the help of the deflection bar, and to this particular deflection bar we have two strain gauges being placed, which is used to measure the deflection being taking place when the robot's series manipulator will be in a moving position with some particular movement. Now, to this particular strain gauge, we will be fixing a potentiometer, which is used to determine the deflection, that is this particular deflection from the original position to the initial position, that is the amount of the voltage, the input voltage, whatever is being determined will be equal to the output voltage. That is how we calculate using the potentiometer, and the deflection has been determined by the by delta, and with this particular formula delta we will be calculating the force in all the four directions, right? In all the three directions, that is in all the four directions, 1, 2, 3, 4, we will be getting the force values, right? So L is nothing but the length of the deflection bar, and P is the amount of the force applied on the deflection bar, and delta is known, and E is nothing but the Young's modulus, that is determined with the help of the material whatever we are taking, we will be taking the value of the Young's modulus, right? And with this with the help of this formula we will be calculating force and movement of the robot series manipulator. Clear? Yes? Hope you have understood today's session, and in the next session we will be discussing about the other type of the sensor, that is a range sensor and linear LVDT type of the sensor, where it is used, how it is used, and what is the use and application of that particular type of the sensor. We will discuss in the next class. Thank you. Signing off for today, Dr. G.
Like, share and subscribe. Hit the bell icon for more updates.